for letting me know. Okay, so we got to finish limits. This fun word indeterminate means when you can't solve or simplify the. Why are we still talking? That's what happens when you don't get sleep. Alright, so indeterminate means you cannot determine the answer. That's what indeterminate means. And if you all want to play Hangman, you should play Hangman using math words, because who would guess indeterminate? Come on. Antiderivative. Oh, you're going to get it? Alright. Play with Brayden, he'll win. Anyways, so an indeterminate function is a function that you can't determine the answer to. Usually that means the function's undefined. Thanks. I love it when it just plays jumping games. What? Stop. What does it mean to be undefined again? I do. Yeah, but when do you get undefined? Mm-mm.
When it cancels each other out.
Equals to 0.
Mm-mm. What equals 0?
The number.
No.
When the thingy equals 0. Oh.
When you have a fraction and whatever's on top, we'll just say some function, and zero's on the bottom, why do you get undefined?
You can't divide anything by 0.
You can't divide anything by 0. Alright, so functions that can be indeterminate are rational function, and that's when the denominator is equal to 0. So to get rid of that denominator, usually you get nice rational equations that factor and cancel out. So that's what you have to do. If you have a rational equation, you have to factor the function, both the numerator and denominator, cancel out any like terms or quantities, because remember, a term is multiplying in between, a quantity is adding or subtracting in between. So after you simplify, then you can plug in and simplify. Okay, so after you simplify the function, then you plug in and figure out your answer. Okay, so it's just an extra step. Not a hard step, as long as you can factor. If you can't factor, then you're in trouble. Okay? Alright. So, if I have number 1, limit of x squared plus x minus 2 divided by x minus 1 as x approaches 1. Looking at that before I do anything, if I plugged 1 into my denominator, what do I get? 0. So that means I need to simplify my function before I take the limit of it. Okay?
Yeah.
Yeah?
Mm-hmm.
You guys having fun looking at whatever pictures you're looking at? Because I don't think that's involving limits right now.
Could be.
Alright. So, until you actually evaluate the limit, you need to continue to write the limit of the function while you're simplifying the function. If you do not, it's not appropriate, it's not correct, it's not right, however you want to say it, it's wrong. Okay? Because you didn't evaluate the limit yet. So, how can I factor my numerator? X squared plus x minus 2.
X.
Thanks, that's what I just asked. How can you factor it? No. x plus 2x minus 1. If you have trouble factoring, usually whatever is in the denominator cancels out with something in the numerator. So if you were stuck with that, you can look at the denominator and say, okay, I have x minus 1. So chances are I have a factor of x minus 1. Otherwise, I don't get an answer. So x minus 1 is the same quantity as x minus 1, so I can cancel those out. Now I can evaluate my limit because I have something that will not give me 0 in my denominator. So, evaluating limits, what do? Plug 1 into my function where the x is, so it'd just be 1 plus 2, which gives me 3. Ta-da! Alright, number 2. I have... Oh shoot, this should be 8. Otherwise it doesn't work. How I want it to. Alright, limit of 2x squared minus 8 divided by x minus 2 as x approaches 2. So if I plug it into the denominator, the value that I'm approaching for x, 2 minus 2 gives me what? 0. So that means it's indeterminate. I can't solve it until I simplify my function. So what can I do in my numerator to simplify my function? I could take out a 2. So I got the limit as x approaches 2 of 2 times x squared minus 4, right? Still divided by x minus 2. What happens with x squared minus 4? Simplifies further into what? What is that x squared minus 4 called? Difference of perfect squares. So I'd have x plus 2, x minus 2, still divided by x minus 2. So what quantities cancel out? X minus 2. So now can I plug in and simplify? So what do I get? The 2 stay in there, because that's a coefficient, so that's not going anywhere. What am I plugging in for x? 2, so 2 plus 2, which gives me 2 times 4, which gives me 8. Ta-da! Why don't you guys try number 3 and number 4? We'll see if you can do it, and then I'll do 5, 6, and 7 with you. So you should have gotten -3, and number 4 you should have gotten -10. Did you drop off the 2? You did. Yeah, you dropped off the 2. Right here. The 2 doesn't go away. Does anybody have questions on number 4 or number 3? Think you got something different? I need to know why. Alright, so if I factored my numerator and denominator, you still have the limit, and I saw some of you did not write that, and I will be a jerk about it and take off points if you don't write the limit every single time until you actually evaluate it. Because it's not right. Until you evaluate the limit, you need to keep on writing limit.
We have to write limits for x every time we do that.
Every time until you actually plug in the number to get your answer for the limit. So when you're simplifying, you have to write limit every single time until you actually plug in the number. That's when you're actually evaluating it. So what can I do in the numerator to factor out anything first? Take out a 2. Which would leave me with x squared plus x minus 6, right?
Yeah.
And I got x plus 3 in my denominator. Chances are that's going to factor into something with x plus 3 in my numerator, right? So I got 2 times x plus 3 times what would give me my other factor to give me x squared plus x minus 6? X minus 2, right? X plus 3 is still my denominator. So what cancels out? X plus 3 is gone. So now, since I can actually plug in, now I don't have to write the limit. So 2 is still there. And then I got x minus 2, which would become what? Negative 3 minus 2, which becomes 2 times negative 5, which gives me negative 10. Did you find your mistake? Okay. Number 5. If you want to help, that's fine. Number 5. If I plug in negative 2 into my denominator, I would get 0, correct? Negative 2 squared would be 4 minus 4 would give me 0. So 5, 6, and 7, I have to factor my numerator and my denominator, because all my denominators will factor for those. So if I factor the numerator, 3x plus 6, what would I get? Three times the quantity x plus 2. What happens in my denominator? X plus 2 and x minus 2, right? That's difference of perfect squares. So what's canceling? X plus 2. So can I evaluate it now? So I can plug in, so I do not have to write my limit again. Once you start evaluating and plugging in, that's when you don't have to write your limit anymore. So what's going to be in the numerator? 3. I don't have any x's there, so I'm not plugging in negative 2. What's going to be in my denominator? Negative 2 minus 2, so I would have 3 divided by negative 4. So it'd be negative 3/4 would be my answer. What about number 6? Limit as x approaches 4. Well, how am I going to get 3x squared? 3x and x. You either have to check your inner pair and your outer pair, or you can do the box method if you wanted to do that. Yeah, we talked about it briefly, but you guys did the inners and the outers, so that's what I stuck to. If you were to draw a box, the first term always goes in the first square. The last term always goes in the last square. And then the two middle terms have to add up to that middle term, and they have to multiply to 3x squared and 8x, so that would be what, 24x squared? So what numbers multiply to 24x squared and add or subtract to 14x? Alright, so multiply to 24 and add to subtract to 14. 12 and 2, right? That was really hard, man. So 12x, 2x. If I wanted a negative 14 but a positive 24, what would my signs be of 12x and 2x? Negative and negative. So, yeah, I will. I will do it. So if I factor out whatever I could take out of 3x squared minus 12x, what can I take out of those two terms? 3 and an x, right? If I'm looking at negative 2x and 8, what can I take out of those two terms? So one of my factors would have to be 3x plus 2, because it's a positive 2. If I'm looking at 3x squared and 2 vertically, what can I take out? An x. If I'm looking at negative 12x and 8, what can I take out of those two terms? 4. That would be a x plus 4. So when you check with the inners and the outers, 3x times x gives me 3x squared. 2 times 4 gives me 8. And then my inner pair and my outer pair should add to negative 14x. Oh, it is both negative. Gosh darn it. Sorry, I need to sleep for it. The reason it's negative is because you have a negative for this middle term right here. So if I check my outer pair, I would have negative 12x. If I check my inner pair, I would have negative 2x. You guys are used to checking the inners and outers and just figuring out the pair that gives it to you. This is something else that you could use, but you don't have to. That's just another way to factor. And it always works.
Do you know
What do you mean what numbers to use?
when you get your numbers in the box?
The first term always goes in the first box.
Yeah.
The last term always goes in the last box. And then it has to add or subtract to negative 14 and multiply to the first term and last term multiplied together. So 3x squared times 8 gives you 24x squared. And that's where the 12 and the 2 come from. So, looking at my denominator, what can I factor out? If I factor out a 2, I would have what left? What happens with x squared minus 16? Factors into difference of perfect squares, right? So 3x minus 2 times 4, or x minus 4, divided by 2 times x minus 4, x plus 4. So, what cancels out in my numerator and denominator? X minus 4, right? So, what do I have left that I could plug in? Three x minus 2, and in my denominator I have 2 times x plus 4. So if I plug in 4, what would I get in my numerator? Three times 4 minus 2, right? What would I get in my denominator? 2 times 4 plus 4, which gives me 12 minus 2, divided by 2 times 8, which gives me 10, 4, 16, which reduces into what? 5/8. When you reduce, if you got 10 over 16, it reduces by 2.
I don't have any more room.
You'll survive. Alright, last one. How would I factor 2x squared minus 2x minus 40? Yeah, no, maybe so. Come on. Take out a 2. So that'll leave me x squared minus x minus 20, right? What about my denominator? Factor out a 5, so I got x minus 5. I still need to write my limit because I'm not plugging in yet, because I still need to simplify my function. So what does x squared minus x minus 20 factor into? X minus 5, x plus 4. And I have in my denominator still x, what? 5 minus x times, oh my god, try again. 5 times x minus 5. So what cancels out? So now I can plug in, which would give me what in my numerator if I'm evaluating my limit? 2 times x plus 4, which would give me 2 times 5 plus 4, right? And then what would I have in my denominator? 5. Can I cancel those 5s? Why? 5 plus 4 is the quantity, and I have to use order of operations correctly, so I'd have 2 times 9, which would give me 18 over 5. Ta-da!